Hi everybody, welcome back to the channel. Thanks for taking the time to check out this video. We're looking at around 32 degrees Fahrenheit today. First real dusting of December. Been pretty mild so far. And there's other things I was looking at doing today, but thought today would be a good day to talk about the KeenPower Jump Starter. This is what's called a Super Capacitor Jump Starter, so it's a little bit different than what you might be familiar with the lithium ion based jump starters. And I think it is worth taking a look at despite its price tag of around $300 at the time of this video. Project Farm actually did a video on jump starters. You guys can check that out, and he talked about this one briefly. It had pretty good ratings, but I think it needs to be delved in a little bit farther just so people understand really a little more how it works, or at least what I understand of how it works. And I'm not an expert on jump starters, but I think that there's a couple things about this jump starter that people should be aware of when and if they buy it. And just a quick disclaimer, I did not get that given to me. I actually own two of them that I purchased during the Black Friday sale. I think they were $200. Again, normally about $300. But the big advantage to them is that, at least what I'm hoping for, is the longevity and how long it's going to be reliable. The lithium ion based jump starters, I'm sure, are great. They're cheaper. If you don't mind that they maybe won't last as long as you'd like, and I don't know how that is depending on which one it is, but I wouldn't expect that they'll be reliable as long as, at least in theory, what the supercapacitors can be. Quick story on lithium ion batteries. I'm old enough now that I lived through the NiCad and nickel metal hydride type battery powered drill drivers. And I remember when DeWalt first came out with the lithium ion batteries, and I bought one of the units. I thought the price was fairly reasonable given it was lithium ion, and I thought I'd only use it just for special cases. I'd continue to use my NiCads and nickel metal hydride batteries because they did work, although they were heavily depleted or degraded over the years. So I parked that in a spot in my house inside, and I never opened the box until about a year later. I went and grabbed it out, and I thought, this thing's brand new. We'll put these lithium ions to work and get the extended runtime, more torque out of the tool, because they were newer batteries relative to what I had. And when I plugged in the batteries, they were dead. Both of them came with two batteries. So I put them on the charger, and neither one would take a charge. So brand new batteries, never even used. A year later, not going to help me out. We're going to use this jump starter today to start this 1978 Isaki tractor. And I actually had this in one of my old videos. I put a new set of rings in it, which these are commonly go through. It's a Bolens G154, which was an imported Isaki tractor. And let me tell you that when it gets cold, they're fairly hard to start. The new rings help in it quite a bit, but batteries are pretty taxed trying to get this thing going. So we will compare it to a fully charged 12-volt battery that I just charged up and put in here. And we'll crank that a couple times, and then we'll try it with the KeenPower by itself and see the difference in cranking speed. One of the advantages of these jump starters, and I don't think it's unique to the KeenPower, it would be true of the lithium ion, is that these units, and hopefully you guys can read this and I'm not too shaky, but this is topped off at 100%, and it's putting out or measuring at least around 15 volts. The neat thing about that is normal lead acid batteries around 12.25 volts or 12.5 volts, and then when you go to start it, of course, there's a voltage sag or dip that usually takes it down anywhere from 9 to 11 volts depending on your starting system. And that reduced voltage requires higher amps, and then also the starter does not get the same amount of power when that voltage sags. These units keep the voltage up higher for a longer period, so you're applying, depending on how much capacity is left in here, you're applying closer to that 14 and maybe even closer to that 15 volt mark, which really helps a bunch with starters. Starters love higher voltage, they'll turn faster, and in the case of diesel engines, you really want that high speed starting. You always like it no matter what it is, but it really lends itself well to diesels, because the faster you can turn them, the less time it has for the compression to leak by the piston rings, and also the less time for the cylinder and the cylinder head and the piston to absorb any energy while you're cranking the engine. Of course, diesels use compression ignition, so you want to keep as much heat into the fuel and air mixture as you can. You don't want it bleeding or leaking by other methods. So the faster you can spin a diesel, the more likely it's going to start quicker and you'll be up and running. The other really cool thing about this that I like, and I don't know because I'm not familiar with the lithium-based jump starters, this will actually be able to be hooked up to a battery that has a depleted voltage state. It cannot be a completely dead battery where you don't have any voltage at all. But if you have some, and I don't know what the lower limit is, but I've hooked it up to batteries that were under 9 volts. And what it does, in lack of technical terms, it essentially sucks the energy from that battery and then steps up the voltage to get it to charge up to the voltage that the system wants, which is right around 15 volts at a fully charged state. And that's a really cool feature, because even though a battery may have a lot of energy, in fact, even an 8 or 9 volt battery that, a 12 volt battery that's down to 8 or 9 volts can still have more energy than what the supercapacitor can hold. But the supercapacitor has a circuitry on board to then take that battery energy and then step the voltage up to a voltage that the starter likes to turn, to get to turn the engine over quicker. So that's a pretty cool feature, and I think it's something to be aware of as to why this is such a neat device. Like any sort of battery powered technology we have of today, we're really limited on the longevity, whether it's a lead acid, the ones I mentioned, or even the lithium ion. You're only going to get so much time. I'm actually impressed. The Tesla cars are claiming 8 to 10 years, I believe. Could be wrong on that, but that's pretty impressive if that's the case. I don't know how they pull that off, but if they do, it's a good step in the right direction, and maybe the new jump starters will give you that sort of runtime, or at least the amount of years of being able to be used, and that would be great. And if that's the case, then this may not be that great of an option, but I'm banking on the fact that KeenPower claims that this is good for 1 million cycles. And myself, I've only jump started a vehicle probably a couple dozen times in my life, and I don't expect ever to hit anywhere near the 1 million mark. But if that's the case, I expect it to work 10, 20, 30 years from now if I'm still able to use the darn thing. And that's where I think the value is. Yes, you can get the lithium ion based battery jump starters cheaper, but if you got to replace them every 3, 4, 5 years, then how quickly will this one pay for itself if it continues to work? So the capacitors are claimed to be supercapacitors. I don't know what defines a supercapacitor versus a normal capacitor, or at least what size in farads they start at considered to be supercapacitors. But they claim this one to be. A supercapacitor has 6 3000 farad capacitors in it. They claim it has a 6000 amp peak current, and I wouldn't put much value in that. That seems to be more, in my opinion, a marketing ploy to compete with the lithium ion based jump starters. The nice thing about this is very easy to operate. It comes with a USB port to plug in and charge your phone, and then it also has a USB type C maybe, or A, I don't know. The wires that are going to the alligator clamps, are, well, they say that's either, it looks like an 8 gauge, so that's actually not very heavy, but they get away with that to some extent by keeping these short. Keeping the wires short allow you to get, they don't have as much loss at higher amperages the shorter they are. So some of the people are complaining that the leads are way too short, and in some cases I could see where that'd be a problem, but as long as you can get this near the battery, you really don't need longer leads, and the shorter these are, the better that is. So that's why they do that. And it's not just them saving money on wiring, although they do that too, but it also helps the unit to be able to generate the amount of power that you can out of it. We just have a normal battery hooked up here, and the battery is fully charged. I don't know what the condition it is, but we're sitting around 12.3 volts, and I want to show you the voltage dip when you go ahead and start, and just show you that characteristic so that you understand why the super capacitor or other jump starters can really help. So we have the fuel off. The engine's cold. Hasn't been run. If I had my temp meter, I would shoot it and show you. You have to just trust me. It's basically what the outside temperature is, 32. So if we turn this on, we'll crank it just a couple times. So you can see we drop down below 10 volts there. And that really creates a problem for the starter, and you could hear how it was not turning over very fast, which is a problem. And now we'll go ahead and hook up the KeenPower just by itself, and we'll see the difference in the cranking speed. Alright, so we just took the positive lead off and we hooked up the negative lead right on the battery. The positive is just up to the KeenPower. Turn this on, and initially it will just tell you what the state of it is. You have to hit the power button again. Now there's a countdown timer so that it doesn't actually apply power for 5 seconds. Now we have power, and now it's doing a countdown for 25 seconds. So a couple things here. We're going to go ahead and get disconnected. And you can see just from that we've lost 70%, according to this, of the charge on the super capacitors. But you noticed how much faster the engine started or was turning when we hooked up the super capacitor versus your battery, because we were much above this, much more higher than the 10 volts that you'll get out of a normal battery. Now this tractor does use glow plugs. There's 2 of them, it's 2-cylinder, and each glow plug will draw about an amp per volt that's on the system. At 12 volts they're pulling about 12 amps a piece, so that'd be 24 amps with both of them, and at 10 volts 10 amps, so something around there. And one of the things about supercapacitors is they do not store a lot of energy, so this is not going to have the energy capacity as your lithium-ion battery powered jump starter. However, because again the advantage of the capacitors is they should really never deplete over time, or at least not in any sort of time frame that in the next couple of decades, I would hope. But one of the questions I seen in one of the reviews for this unit was how would this work with glow plugs? And the answer is, anytime that you're pulling from these capacitors, you really don't want any sort of draw on these things that are going to eat up that limited supply of capacity that they have relative to batteries. But that being said, it will run the glow plugs, and we're going to go ahead and try that right now. And we'll run that and see if you know anything about glow plugs. There's the old school, they have a inline wire that heats up and shows that the glow plugs are warm. That usually happens after about 15 or 20 seconds. Now this only operates for 25 seconds, and I believe that they're doing that because if you leave your battery hooked up to this thing and you turn it on, it'll start dumping the energy back into the battery because it's at a higher voltage potential. So in some cases it may actually be better to disconnect the battery, especially if the battery is weak and you use the battery to charge the supercapacitor. That way when it turns on and starts providing power, your battery is not absorbing it back in as the capacitor jump starter is discharging. But you don't have to, and so if you have a vehicle that's in good running condition, the battery does not absorb the power that fast. Therefore you'll have still a lot of power going into your starter system to turn your engine. So we'll go ahead and turn this on one more time and run the glow plugs for a few seconds, and you're going to watch the power start to decrease. So we're burning it up quick. Down to 2218. We're dropping 4% every couple seconds. Let's look on our indicator, and we're still not very warm. Down to 11 volts. Indicator's just starting to heat up. Let's give it a try. Oop. Okay, so now it's telling us we're down to 0% on the capacitor. Voltage is at 11.4, so it considers 11.4 volts 0% charge. Now, in order to get that back charged up, we're actually going to use the battery, because we know that the battery has some charge left into it. And so let's get that hooked up here. And here's where these short wires are a problem. So we'll turn that on, I believe. Yeah, so you need to turn it on to charge it. You can't just hook up the leads. And so let's see how long it actually takes here to charge this up. Alright, you can see when you're hooked up to a battery, it can charge pretty quickly. They claim 2 or 3 minutes, and that's probably going to be about right. Alright, we're at 15 volts. It shut off. Was a little over about 3 minutes, exactly what they said. Now we're ready to go again. And I think what I'm going to do is I'm going to set the fuel up so that we can actually start. And I'm not even going to run the glow plugs, although these engines probably really like to run the glow plugs. And we'll just see, since we can turn it faster, maybe we don't need it. And yes, we have been running the glow plugs in here, so we are putting a little bit of heat in this engine, but it's not significant enough to really make that big a difference. Normally these engines will not start without glow plugs, but because we're turning it so much faster now, I'm actually going to try it without using the glow plugs, just cranking the engine and see if that will turn fast enough to create enough heat to start the engine. If not, we'll recharge this and then use the glow plugs. Now every time I do this, I'm putting some heat in the engine. I'm getting it closer to wanting to fire. But I just want to show this just to give you an idea, and again kind of point out the ability of this to be able to crank an engine like this versus the battery. Okay, so despite us being able to crank it faster, it shows you how valuable those glow plugs are. We'll recharge this, and then we will run the glow plugs and then try cranking it again just off of the KeenPower jump starter. All right, this time we're going to run the glow plugs for about 15 seconds. That's going to pull our super capacitor down, and then but we should still have enough energy left in here to crank the engine enough to get it started. So let's do that. One of the other questions people may have about these is how long will it stay charged once it's charged? And capacitors will typically naturally bleed down much quicker than most batteries, in my experience, and I think that's pretty well known. In fact, a lot of the older electronics, and maybe even today, they had resistors across the positive and negative leads that would slowly bleed capacitors just to release that energy that's built up in them. But in my experience, this one, I haven't had it sit too long without charging it, but it will definitely make it at least 2 to 3 weeks, and I know that's nothing compared to the lithium-ion batteries, but it's much better than I expected it to be for a capacitor, given my experience where capacitors usually bleed with that internal resistor much more quickly than what this does. So it will hold a charge for a couple of weeks, and you can see how fast it charges when you hook it up to any sort of 12-volt power source, and that can be any 12-volt from just the alternator of the vehicle, as we've shown here, to another 12-volt battery, of course, or even a DC power supply that has a 12-volt power output value. So a lot of options to be able to charge this up, and it charges fairly quickly along with the USB. From a fully dead state, I've read where it's 4 hours to charge this up. I've charged it from a 50% or so energy capacity to 100 in just about 10 or 15 minutes off of that. And it's actually pretty amazing that you can charge this off of a USB cable and then apply it and start it to a vehicle. I find that pretty impressive. So I hope you guys learned something from this. Of course, there's a lot more to it than what I've said, but I would say that I would definitely buy it again. I own 2 of them just to keep them in 2 different locations, so I can always have them handy. I don't forget it in the time I need it, because when you need a jump start, it's usually not anticipated ahead of time. And the fact that if this lives up to what I believe it will, 5 years from now I can grab it, hook it up, it'll work just like it does when it's new, and to me that's worth the money that they're charging just for that fact. And the fact that now you can actually go around and use this to start equipment that has depleted batteries that just will take a long time to get charged, or will not fully charge at all past the voltage maybe required to start the vehicle. And so this will then extend the life of those batteries, so you can save some money there, especially when batteries could be upwards to $100 or more a piece. You can put that towards a super capacitor and take it around and get that extra life out of those batteries, as you can the lithium ion as well. I understand that, or even using a new battery, but this is going to be much lighter. It should last much longer. You don't have to worry about that eventual time when it's going to fail, and it's usually a time when you're not thinking about it, when you're relying on it. And so I'm hoping that the reliability of this just justifies the cost in and of itself. The weak point is probably the electronics, the step-up voltage converters and the circuitry inside. And I'm hoping that those really do last a long time, and we'll see. And I'll try to update in a few years the reliability of this and let you guys know how it continues to operate. So thanks for watching, and we look forward to making another video and seeing you back at that one.